Every year, millions of coconut water are poured down in the drain in the Philippines, a byproduct of coconut oil manufacturing. But what if that waste could become the next great natural sports drink? That's exactly what this study is set out to answer. Researchers worked with 3 different coconut varieties: the aromatic dwarf, the Kathleen dwarf, and the Laguna tall, harvested from Zamboanga City, ranging from 5 to 12 months. A published dataset from Mendeley data captured each coconut physical traits with circumference, weight, and its biochemical profile with glucose, sodium, potassium, chloride, and many more, with a total of 119 samples in total as its raw material.
The first problem the study tackled was, how do you tell these apart without cracking them open? The answer was machine learning.
We used a program called Weka to test 8 different classification algorithms, from simple baselines like 0R to more powerful ones like the naive Bayes, logistic regression, and J48, a type of decision tree. The data went through 3 treatments: raw, normalized, and standardized. Each algorithm was tested at a 70-30 train test split. The winner? The J48 decision tree, hitting 86.11% accuracy on the raw dataset.
Here's what makes the decision tree elegant. We only need 3 physical measurements. First, we check the transverse circumference. If it's 49.5 cm or less, we use the longitudinal circumference to tell between the aromatic dwarf from the Laguna tall. But if it's larger, we weigh the fruit. If it's under 2 kg, it's Katigan dwarf. If it's over 2 kg, it's Laguna tall. Simple, fast, non-destructive. The model was then translated into an interactive simulation in SiteMaker, where farmers can plug in real-time physical measurements using sliders and get a real-time variety prediction.
Starting so, the study moved to the second question. Can you blend these coconut waters into a fully natural isotonic drink with no additives? Researchers used linear programming in RStudio to minimize one thing: total glucose, which is the objective function. The blend had to hit set international isotonic standards where at least 230 mg of sodium, 170 mg of potassium, and 355 mg of chloride are found per liter. At 12 months, all 3 varieties reached their lowest glucose point. Aromatic dwarf stood out as it had the lowest glucose at 1.42 mg per liter and the highest natural sodium and chloride. Laguna tall was selected as a potassium booster at 62.4 mg per liter. Katigan dwarf was excluded as it offered nothing that aromatic dwarf or Laguna tall didn't already do better. The model set up 5 decision variables: volume of aromatic dwarf, volume of Laguna tall, and supplemental amounts of sodium, potassium, and chloride. The question was simple: do those supplement variables equal 0? If not, 100% natural is mathematically impossible.
The simplex method gave a definitive answer. The optimal 500 ml blend is 100% aerod, minimizing glucose at 0.7 mg. But the electrolyte gaps were massive. The formulation still needed 118 mg of sodium, 32 mg of potassium, and 159 mg of fluoride added externally. The feasibility graph told the same story visually. No overlapping visible region, no natural combination of these coconut waters can meet isotonic standards alone. So here's what the science tells us. The Philippine coconut water, specifically the mature aerod at 12 months, is a near-perfect low glycemic base for a sports drink. But nature alone isn't enough. A hybrid approach with mineral fortification is necessary to cross the finish line. The coconut gets you most of the way there. Science closes the gap.